Hello, myself Dakshayani C, Assistant Professor of Chemistry, Government College for Women, Mandya. Today I am going to discuss about the topic electrochemistry for the course BSc, subject chemistry, paper physical chemistry. In the in this session we are going to discuss about electrochemical cell, which contain electrolyte concentration cell, that is another type of electrochemical cell, concentration cells without transference, concentration cells with transference, electrolyte concentration cells. In these cells, two identical electrodes are dipped into metal ions of different concentrations and ions of different activities. Here, the both the electrodes are of same metal, zinc, and these are contact with the solution of the same ion, that is the zinc 2 plus ion. Hence there will be a difference in the concentration of its electrolyte solution, which is separated by the salt bridge. Therefore, the activities of these ions, however, that is be a different. This salt bridge represented by, you already knew that a double ion put in between the two of cells. Yeah, the concentration cell without transference we have taken as activities in the ions of the two electrolytes surrounding the electrodes with respective electrodes. So one is undergone reduction and another one that will be in the oxidation. So activities of A1, that is there undergone oxidation, activities of A2 that will be in the surrounded by that electrode that will undergo reduction here. The net process, that's the overall reactions, that is activity of the metal ion at A2, which is about activities of the A1. In that, the net process that involves transfer of, that is 1 mole of metal ion from the solutions in which activity A2 to the solutions in which the activities of A1, then what is the EMF of that right hand side cell here? So ER, which is equal to E standard cell minus RT by NF ln of activities of A2, because of here, that is the right hand undergone reductions, therefore oxidation from the next relationship activities of oxidation or the reductions, therefore E cell minus RT ln of A plus here, because of that is you are going to, that is the concentration of A2 is greater than here. So therefore you are going to neglect that A1, because of it is there a reduction potential, therefore put in a ln of A2. So overall cell, you know that's the overall cell, that C cell is equal to ER minus EL. Then you are going to get, that is because of these undergone oxidation and reduction. Therefore the next relationship is equal to RT by NF ln of A2 by A1 here, because of the concentration of A2 is greater than A1. Therefore that will be a reduction over oxidation. Otherwise that will be A1 is greater than A2, then it can be A1 divided by A2. So substituting these activities A1, A2 by molalities M1 and M2 and nu1 and nu2 are the activities coefficient, then this equation rearranged, that E cell is equal to E into RT by 2F ln of, that is nu2 M2 nu to the nu1 M1. So here 2 represent the number of electrons that will be involved in the chemical reaction. So this is the one that will be a cell without transference. So cell with transference. Here consider the cell with the concentration cell with the transference, the two electrolyte solution, that is what we taken as here HCl, are present on the sides of the here, that is you all know that will be a a membrane usually that will be separated by these two solution. Here the speed of the ions are different due to the which because of H plus ion and the chloride ions, the speed of the ions which is different. Therefore, due to that one, which electrical neutrality is not present in the membrane. Therefore, the potential difference arises at the junction of the two liquid membranes. This which is called as usually liquid junction potential, it is there. So this is the cell representation of this with the transparent cell. If it is 1 farads of electricity is withdrawn from that cell, then the changes, that is the energy changes, EMF of that will be changes taking place here. Then the overall cell reactions depending on not only that is the potential difference at the electrode and the solution interface, and also here and the diaphragm. Therefore, E cell of that one depending on both the EMF of the electrode plus EMF of the liquid junction potential. So, like that only, if it is overall cell, one is acts as an oxidation potential, another one is acts as a reduction potential. So which is an oxidant we called as an anode, which is undergone a reduction, that is what we called as an which is an cathode, it is there. So then the reactions in that is in the C1 concentration and the C2 concentration, what is the changes in that, what kind of the reaction is going on at the liquid junction potential. If T plus transference of H plus ion, that is we represented by the transport number, that is a T plus for the H plus and T minus for the Cl minus ion. If it is T plus, that will be transfer from left to right, that is T plus H plus ion to left to right. At the same time, that is the Cl minus from that is the right to left, that will be, it will goes to, that is a cathodic or an anodic side. Therefore, that is overall you taken as the reactions between at the anode, at the electrode, at the liquid junction potential. This overall we are going to taken as the reactions, and also left and right reactions, overall reactions we are going to return in that in the form at equilibrium. That is the same thing, that is you know that is the T plus plus of T minus, which is always unity. From that, knowing that will be, we are going to rearrange that equation into this form. Therefore, if it is E cell, I already explained you, that will be in with the transference, the overall cell will not only depending on that is a potential difference between the electrodes, and also it will depending on the, that will be potential difference in the liquid junction potential also. Therefore, here that is a delta G, the change in the free energy, which is equal to, that is the E electrode is taken as a standard because of it is in a hydrogen sheet, it is that. So electrode that will be taken as there is 0, then we are going to calculate only a, that is a potential difference at the liquid junction potential. So if it is in the activities, in the form of activities, for example, if it is T minus moles of HCl which is transferred from right to left, then what happens to these activities of change in the free energy. So free energy, by using the Gibbs the Ham equation, so these equations can be written as delta G is equal to, so we have taken a T minus as a common factor, that will be a mu, that is a H plus plus or T ln of A, that is the activities of, that is H plus A2 in that whatever that will be in the right hand side, and plus that is a mu of Cl minus plus lot of, that is the A2, here that will be A2 is there. So what happens to this, if it is transferred, that is Cl minus into that HCl of that one to the left hand side, that will be this kind of relationship that we are going to substitute that one in place of, that is the H plus A2 and T minus Cl minus A2 and H plus A1 and T minus Cl minus A1. So by Substituting all those things, rearrangement, finally you get delta G is equal to T minus RT into ln of activities of H plus and Cl minus of A1 and activities of H plus and Cl minus of A2 here. So overall that will be activities, that will be a square of that one. Therefore, it become delta G 2 T minus RT ln of HCl, A1 HCl and A2 HCl. That will be a equation 1. So for the here, that is this is the with liquid junction potential. You are going to calculate only with liquid junction potential. So for spontaneous functioning of the cell, you must know that A1 activity is always greater than A2 activity. It may the flow from left to right side. So it is the spontaneous reaction. So cell without liquid junction potential. So I am already we knew about that cell without transference. It means that cell without liquid junction potential, we are going to put in a salt bridge here to minimize the liquid junction potential. Then the overall reaction, so whatever that will be, look at that, if it is undergone oxidation, it is there, then the cathode is undergone whatever that will be a reduction, it is there. Then overall reactions without liquid junction potential, then without liquid here minus RT ln of that is A1, that is HCl over A2, because of here number of electrons involved in that same that will be a cell, that will only one. So we put on that is RT by that is activities of HCl, and it will be in the here, that is A1 to the activities of A2 here. So this is the E cell of the without liquid junction potential. But liquid junction potential, they calculated by E cell of with liquid junction potential minus E cell of without liquid junction potential. Then only we are going to calculate the actual liquid junction potential of that cell. So here, that is the liquid junction potential is equal to minus 2 minus ln of this one from the previous equations. So you are going to rearrange like that. Then you have to get 1 minus 2 minus RT by ln of that is A of A1 of HCl over to the A2 of HCl. So here that will be know that that's a T plus T minus, which is equal to 1. So from that you are going to rearrange that, they get an equation of that is the 3 from 1 and 2. We can write this equation. From that equation 3, we can predict the sign of positive or a negative of the liquid junction potential very easily. So here it is the anode and the cathode. Look at that. That's the A2. It is pass from the A2 to A1. That is a transfer of A2 to A1. It means that if it is transfer of that one, the concentration of A2 is greater than A1. Then that T minus, it is go to the here. That's a A2 to A1. That's what T minus is greater than T plus. So A2 is greater than A1. Then liquid junction potential, that will be a positive here. Here look at that. That's a, even though A2 that will be a greater than A1. Look at that. A2 is greater than A1. So if it is, it will be driving force if it is there, and T minus is less than T plus. That is a T minus. That is whatever that will be a even though that is a here, look at that, that's A2 is greater than 1, that is the T minus less than T plus. If that kind of the ions is there, then the is a liquid junction potential is, it will be a negative, and it is in the reversible manner. So therefore, E liquid junction potential is negative. It is same thing if A1 is greater than A2, it means that there will be a transfer of A1 to A2 at the liquid junction, and then T plus is greater than T minus here. T plus is greater than T minus, then it is the liquid junction, that would be it would be a positive only. So if it is A1 greater than A2, that will be whatever that's a T plus less than activity at some of the T plus is less than T minus, then it is in the reversible manner. Then the liquid junction potential at that cell, which is equal to negative. These are the reference and sources for preparing the study material for this session. Thank you.